Hi everyone, welcome to our video on using integration by parts to integrate log functions. So whenever there's a log function involved and u substitution doesn't work, so for instance, I'm going to erase this in just a second, but usually we would let u equal ln of x and then du would be 1 over x, but there's no over x in any part of this integral, so that means this does not work. Okay, this is typically what we do when we see a log function. At least this is the first thing we want to try when we integrate. But when this doesn't work, well, then we have to use integration by parts. Okay, so this is an integration by parts formula or problem when u substitution does not work by itself. And don't do this. I'm going to erase this in a second. Don't do this. This is the wrong thing as well. That would be the derivative. Okay, so don't fall for that trap. Okay, well, anyway, so it is integration by parts. And what we do with it, I usually set it way over here, so where we have our u. And our u in this case would be the natural log. So whenever let's go ahead and write it. Integration by parts with ln is usually ln is instantly your u portion. Okay, so your ln whatever is your u. And then we usually set up our dv. Our dv in this scenario is usually whatever's left over. Okay, so in this problem it would be the dx. Okay, so dv, so I'm just setting it up. So dv, actually let me write it like this. So ln of blank, instead of just dx, I'm going to write it as that it is the leftover. So on this problem it was just ln of x that we had, so this is our u. And then the leftover stuff, well, that's going to be the dv. So we have u is ln of x, dv is dx, and then with our u, go ahead and get the derivative, which would be 1 over x. And then the dv, we can find v, which would be x. Okay, so it's just doing the integral. It really is a 1 in front, remember, so a constant 1 has the integral of x. And with these, we don't do a plus c, we just kind of set it up just like this in this small little table. Okay, so I'm going to kind of block this table in a box. Okay, and then after that, so with our integral, let's set it equal. What we usually do is, or the way I think of it is we do our diagonal. This will times this. So these just multiply each other, circled in the blue, so that, and you could put it in any order. I will put the x first. So we're going to do x times ln of x, and then we always minus these ones. Let's kind of do a little cup under it. Minus those ones with the integral in front afterwards. So it would be x times 1 over x, and then just attach dx. Oops, I guess I accidentally forgot the dx on that. Okay, so that's where that dx would have come from. Okay, and that is our formula. So that's how I usually think of it. I just make the table and think diagonal and then straight across. Okay, that is the formula right here. This is the exact formula if you wanted to use it just like that. But I think it's easier to see it in this visual with the table. Okay, and then now, often, this integral simplifies nicely. So it would be just x ln of x minus, notice x times 1 over x would reduce, and we would be left with just the integral of dx. And then often with integration by parts, this integral now is very easy to do. X ln of x is left over. Minus this integral would be minus x. And then, like always, at the very end, add your c. And that's it. There we go. Okay, and then again, you could always quickly check with the derivative. The derivative of this first part would require the product rule. It would be x times 1 over x plus 1 times ln of x. So that was doing the product rule on the first term there. And then minus 1 would be the derivative of x. Notice this would cancel to be 1. Minus 1 would all be 0. And we're left with the ln of x. And that's it. Okay, so it worked. Okay, so the ln function is set your u equal to the ln function and then your dv to the leftover. Okay, so let's try that on this one then. Okay, so we'll take that same strategy. Let me go ahead and kind of leave that here. I'll kind of highlight it. This is what we usually like to do. Okay, so let's try it. So we see it's integration by parts. Again, regular u substitution would not work. Okay, so just to show, I'm going to erase this. So this is no good. Okay, so I don't even need to keep going. Let's go ahead and just erase. Okay, so regular u substitution's no good. So then let's try integration by parts. Okay, so again, I usually put it to the side. We're going to say the ln portion is the u. So we have ln of 4t. And let's go ahead and get our du immediately. So du would be, okay, so the derivative of a log is put that 4t down below, and then do the derivative of that expression to put up top, and then attach dt, and then we can see, oh, 4s would just cancel. So this really is 1 over t dt. Okay, so that is the du right there. Let's go and keep it in that line just like that. And then let's set up our dv. Well, the dv, again, is usually just the leftover. So I said this here was the u. So the leftover is the t cubed. And then the dt is still just attached, just like that. And this is just letting us know we're doing the integral. Okay, so doing the integral gives us regular old v. Now use your power rule for this. Add 1 to the power, so it'd be t to the 4th, and then divide by that new power there, divide by 4. Okay, and again, no plus c is needed on integration by parts until the final step. All right, well, now we've got our integral, we've got our setup, and then now let's continue with the formula. Well, the formula is really in a visual with the colors here. This multiplies that straight across. Okay, so the ln, and again, I usually put this portion first because the ln is usually best to leave last. So let's do it as t to the 4 over 4 ln of 4t, just like that. And then always minus, let's do the simplified one with that one, straight across. So diagonal, straight across. And then, but minus the integral. So don't forget the integral symbol. Put that integral symbol in there. And then we have whatever order. Let's put the t to the 4 over 4 first. And then it's timesing the 1 over t dt like that. Okay, and then from here we can see, oh, the t to the 4 and the t would reduce. So let's simplify. So the blue is good to go. I'm just going to change it to black ink, though. So t over 4 times the natural log of 4t minus the integral. The t to the 4 and the t reduced to t cubed over 4. And then dt still attached. And then now this integral is very easy. There's no problem with it. Let's go ahead and finish it off. So my first term is still just the same. T to the 4th over 4, ln of 4t. And then minus this integral as well, use the power rule. So add 1 to the power, so t to the 4. And then times the denominator by that new power. So that 4 would get times by another 4 to give us 16. And then now that there's no more integral signs, throw in that plus c at the end. And there it is. It's all done. Okay, and again, real quick, check. So we are done with these ln's, but let's check it real quick. Okay, so this also requires the product rule. We would have 4t cubed over 4 times the natural log of 4t plus, okay, just the first one, just the t to the 4 over 4 times the derivative of the natural log of 4t, which would be 4t in the denominator, 4 in the numerator. And then minus, doing the power rule to this, it would give us 4 over 16 and then t cubed. So I'm doing my derivative power rule. And then now let's see what simplifies. Okay, so in this first term, let's keep it red. In this first term, notice the 4 and the 4 would cancel. And we would have, let's go ahead and write it, t cubed ln of 4t. And then over here we've got plus, but look at what cancels. We have, well, the 4s and the 4s cancel. The t and the t to the 4 would reduce to t cubed. Okay, so that becomes t cubed over 4, like that. Okay, because all the 4s canceled except that 4. And then minus, well, that term right there, this one, the 16 and the 4 would reduce to be minus t cubed over 4. And then these two would reduce to become 0, and then we're left with just this, which is what we started with in our original integral. So it worked. Okay, so that's why it's always good to check. Okay, so integration by parts, very similar setup. When you have when you have ln, use u equals the ln. and then the dv is the leftover stuff. Okay, and that's that. And then on this, it's erased now, but remember, if you have e to the x involved, it's usually that's where the dv would be. So u is the x expression. Okay, so that's our two kind of big ones for integration by parts. All right, so that's it. Thank you for watching. If you have questions, please let me know. Otherwise, I'll see you again soon.